Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. You just merged a tiny change. Now 2,000 users can't log in. You're staring at a million-line codebase and you have no idea where to start. Part 5 got you solid with Git. Today, you're going to add the skill that turns a blind panic into a systematic hunt. We're learning how to debug massive codebases, and we're doing it with Claude Code Writing Shotgun. According to multiple developer productivity studies, software engineers spend a significant portion of their time understanding existing code rather than writing new features. That percentage only increases when you're debugging a system you didn't build. So the difference between a senior engineer and someone stuck at 2 in the morning isn't typing speed. It's having a repeatable system for finding the problem quickly. Here's what you'll be able to do. 1. Isolate a bug in a codebase you've never seen, using divide and conquer and backtracing. 2. Use Claude Code to turn hours of manual searching into minutes of targeted analysis. 3. Ship a regression test that slams the door on the bug permanently. Let's build the system. Experts on large codebases have a different instinct than beginners. They don't jump to, "How do I fix this?" They hunt, "Where is this actually happening?" Career Village interviews with senior devs make it blunt. The hard part is finding the source. Once you know where, the fix is usually obvious. So our first technique is about narrowing the search area, not patching symptoms. Divide and conquer means you slice that million-line monster into logical segments: authentication, payments, user profiles, and then test each one until the bug reveals itself. Instead of reading everything, you work from the outside in: whole system, suspicious area, candidate file, broken function. Each step cuts your search space by an order of magnitude. Before we move on, let's lock in the 2 ideas that make experienced engineers so effective. First, what does divide and conquer actually mean when debugging? It means breaking a large system into smaller testable sections until you've isolated the component that's actually failing. Second, how does an experienced engineer think differently from a beginner? Beginners immediately ask, "How do I fix it?" Experienced engineers first ask, "Where is the problem really happening?" Once you've identified the correct location, the fix is usually much simpler. That shift in mindset is what allows you to debug large systems without feeling overwhelmed. The other side of the same coin is backtracing. You start at the visible symptom, that ugly 500 error, and walk backwards through every layer that touched the request. Web server, API gateway, the application service, the database call. At each hop you verify, is the data still correct here? If it is, the bug is deeper. If it isn't, you just found your boundary. A payment processor was double charging customers. The dev started at the billing API response. The duplicate was visible there. One hop back to the order service, still clean. Another hop back to the payment gateway callback. The payload looked fine. But when she reached the database trigger that wrote the transaction record, she found the missing constraint. It was inserting a second row every time a retry fired. Each layer gave her one clue. She never had to read the entire system. Let's test another core debugging skill. When you're investigating a production failure, where should you begin? Start with the visible symptom, the error message, failed request, or unexpected output, and trace the execution backwards through each layer of the system. At every step, ask one simple question: is the data still correct here? The moment the answer changes from yes to no, you've found the boundary where the bug was introduced. That's the power of backtracing. It helps you locate the source without reading the entire codebase. Print debugging still earns its keep, especially when you let Claude inject the exact log statements you need. I pointed Claude at this Python function that was crashing because user was sometimes none. It added 2 lines, printing the user object and its type, right before the dangerous call. Now, when the bug triggers, the logs tell us exactly what value caused the crash, without even opening a debugger. After strategic print statements, you've narrowed things down, but now you're staring at a 300-line stack trace. That's where automated debugging earns its keep. IBM defines it as using analytics and AI to accelerate error localization. Instead of grepping for error strings, paste that stack trace into your terminal and ask Claude, why is this exception happening? Claude scans patterns across your entire repo, checking related commits, similar stack traces, and code dependencies, then points you to the exact file and line. It even explains the root cause, like a missing null guard 2 method calls ago. You go from hours of manual hunting to a single command that hands you the answer. One warning: don't blindly accept the fix it suggests. Treat it as a starting point. Validate it with your own understanding and always run the tests. Let's see automated debugging in action. You've got a Node.js stack trace screaming, type error, cannot read property of null. Paste that trace into your terminal, then ask Claude to analyze it. Claude scans the error, traces the call stack, and points you directly to auth.js, line 42, where a null user object was accessed without a guard. It even explains the root cause. The authentication middleware failed to set the user object before calling the next handler. Within 30 seconds, you know exactly where to fix, not just that something broke. Here's why your debugging fails. You race to change the first error line without pausing to understand what the code is supposed to do. You assume the bug is isolated, forgetting that one module might be breaking another 5 layers deep. And you never open the test folder, missing the executable documentation of intended behavior. Avoid that triple trap. Understand the full context before you touch a single line. Let's track down when a bug was introduced using git bisect and have Claude run the test for you. Start the bisect session with git bisect start, mark the current commit as bad, then specify the last known good commit from last week. Now the hard part, testing each midpoint. Instead of manually checking, ask Claude. Write the git bisect run command using the checkout test. It suggests running the failing test automatically. Git now marks commits as good or bad until it pinpoints exactly the commit where things went wrong. Claude even interprets the final output. Commit D4E5F6 removed the null check, causing the crash. Quick review. Which command starts a git bisect session? The answer is git bisect start. After identifying your current broken commit as bad and the last known working commit as good, Git automatically walks through the history to isolate the exact commit that introduced the bug. Instead of manually inspecting dozens of commits, you're using a systematic search strategy to find the source of the regression. Here's what almost everyone gets wrong. AI won't debug for you. It can mislead if you don't guide it. Last week, a developer pasted a stack trace into a chatbot, got a plausible fix, and that fix introduced a security hole because the AI assumed the user was always authenticated. The real power is combining your systematic method, divide and conquer, backtracing, with AI's speed. You stay in control, and AI becomes your turbocharger, not the driver. With that mindset, let's put Claude to work explaining unfamiliar code so you can understand it quickly, not just blindly patch it. Take this Java transaction processor, part of a banking backend you've never touched. Instead of stepping through the debugger for hours, paste the method and ask Claude to break it down line by line. Claude annotates each step. It warns that load account could return null, points out the missing exception after null check, and highlights a potential crash where the fee calculator's null result could cause a balance comparison to fail. In seconds, you've mapped the entire function's behavior without reading a single line of stale documentation. Here's a secret. The test suite is the most honest documentation you'll ever find. Open tests, testmodels.py. There's a test called test create user with valid email. It creates a user, calls save, then asserts the email is stored correctly and a profile is generated. That test isn't opinion, it's executable truth. When you read a test, you see exactly what the system expects: required inputs, the sequence of operations, and the guaranteed outputs. The common mistake is treating tests as just verification and ignoring their explanatory power. Next time you're lost in a giant codebase, skip the outdated wiki and dive into the test folder. What you find there will tell you what the code should do far better than any comment. Now pin the bug by writing a failing test. Ask Claude, write a PyTest test that reproduces the null card bug in the payment service. Claude generates a test that calls charge with a null card, expecting a value error. Run it, and it crashes. The bug lives. Now you have a concrete, repeatable failure that proves the bug exists and will break again if anyone removes your fix. That's test-first debugging. No speculation, just a red test that turns green when you finally solve it. Here's a technique that saved me more times than I can count. Rubber duck debugging. Describe the bug out loud to something that doesn't know your code. In our case, that something is Claude. Open a fresh chat and start explaining. The payment service crashes when a user has no card on file. Here's the sequence. The front end sends a request, the API gateway forwards it. The payment service calls the card processor. Wait, we never check if the card object is null before creating the charge. As you lay it out, the gap appears. Claude can then confirm your hypothesis or ask clarifying questions. Talk through the problem, and the answer appears. No magic, just clarity through articulation. Let's check your understanding. Why does rubber duck debugging work so well? Because explaining a problem out loud forces you to slow down and examine assumptions you didn't even realize you were making. As you describe each step of the workflow, missing validations, incorrect logic, or flawed assumptions often become obvious before anyone, or anything, suggests a solution. Claude Code can ask helpful follow-up questions, but the breakthrough usually comes from organizing your own thinking. A bad commit sneaks into production, and suddenly logins break. You don't have to manually unpick every line. Git revert creates a new commit that exactly reverses the change. But you need to know which commit to revert. Feed Claude the recent log and the stack trace. It'll pinpoint the commit that removed a null check or broke the validation. One git revert later, you're back to the safe state, and Claude confirms the fix matches the expected behavior before the bug. Fixing the bug is only half the battle. If the same mistake slips in again, you're back to square one. A CI pipeline that runs a regression test on every push slams that door shut. Here's the flow. You push code. The CI server fires up, runs your unit tests, and then the brand new regression test you wrote to reproduce the bug. If that test fails, the pipeline halts and alerts you immediately. No deploy, no surprise outage. The regression test becomes your automated safety net. The difference between a superficial patch and a real fix. When users hit a user not found error, the knee-jerk reaction is to reset their password or bounce the server. Those actions treat the symptom, not the disease. The real culprit was a missing validation that allowed a null user ID to land in the database. Fixing the root means adding that validation, cleansing the bad data, and locking the constraint so it can't happen again. One side makes the ticket disappear for an hour. The other makes it impossible to reopen. When a variable like max retries suddenly causes timeouts, you need to know who changed it, when, and why. Rather than wading through pages of Git log, ask Claude to search the entire history for that specific variable. It returns a clean summary, commit hash, date, author, and the exact reason pulled from the commit message. You can immediately see that max retries was bumped from 3 to 5 to work around a slow external API, and you can decide whether that's still the right call today. A profiler report lands on your desk. One function, optimize inventory, takes over 1200 milliseconds to run, while nearly every other function completes in well under 100 milliseconds. Instead of manually inspecting every loop, ask Claude Code to analyze the profiler output and explain where the time is being spent. Claude highlights the nested iteration as the likely performance hotspot and suggests replacing repeated linear searches with a hash-based lookup. After reviewing the recommendation, implementing the change, and validating the results with another profiler run, execution time drops dramatically. Claude helps identify promising optimization opportunities, but profiling and measurement are what confirm the improvement. A single checkout request in a microservices world hits the gateway, then auth, then payment, then the database. Without a correlation ID, you have 4 separate log entries that might as well be on different planets. With that ID, every hop stamps the same identifier into its logs. Claude can ingest those logs, follow the trail, and tell you exactly where the request slowed down or threw an error, often pointing to a specific service and line of code in seconds. Debugging doesn't stop at reading code. In modern distributed systems, logs tell you what happened, metrics show how the system is performing over time, and traces reveal how a single request travels through multiple services. When these 3 signals are combined with Claude Code's ability to analyze code and explain dependencies, diagnosing production issues becomes much faster and far more systematic. Let's make sure this idea sticks. When a request travels through an API gateway, authentication service, payment service, and database, what allows you to follow that single request from beginning to end? The answer is a correlation ID. Every service records the same identifier in its logs, allowing you to reconstruct the complete journey of a request across multiple systems. Without correlation IDs, each service becomes an isolated island of log messages. With them, distributed debugging becomes a connected story instead of a guessing game. When you can't even tell where the bug is hiding, treat the code like a binary search. Claude helps by commenting out exactly half the function and running the associated test suite. If the bug still reproduces, you know the problem lives in the remaining half. Then you comment out half of that and repeat. Within a few iterations, you narrow a 1,000-line file down to a single conditional. In this case, the suspicious block revealed a division by 0 when quantity equals 1, a defect that would have taken hours to spot with traditional line-by-line reading. Legacy codebases don't come with onboarding docs. You get a 10-year-old PHP file, variables like $thing, and functions named process and do stuff. Point Claude at that mess and ask it to explain the module and its dependencies. It returns a plain English summary of what the code actually does, which functions call which, and, critically, a mermaid-style diagram that maps the external dependencies. In this case, it flagged a direct link to a deprecated mail library, instantly telling you where the next outage is likely to come from. One of the biggest advantages of using Claude Code is that it helps you understand unfamiliar systems quickly, but don't let that knowledge disappear when the debugging session ends. Export your conversation as Markdown, summarize the root cause in your pull request, or add the explanation to your team's documentation or internal wiki. Future engineers shouldn't have to rediscover the same problem from scratch. Good debugging doesn't just fix today's issue, it leaves behind documentation that makes tomorrow's debugging faster. Instead of guessing where to stop execution, highlight the suspect region and ask Claude exactly where to set breakpoints. It reads the code, identifies control flow changes, and returns specific line numbers with a short reason for each. Click, set, and you're ready to trace. An e-commerce site started throwing 500 errors during checkout, right before a holiday sale. The dev had never touched the payment module. He used divide and conquer to isolate the problem to the transaction processor, asked Claude to trace the payment flow and explain the state machine, ran git bisect with Claude interpreting test results at each step, and pinned the failure to a misconfigured retry policy in a deployment that morning. He then wrote a regression test that simulated exactly that scenario. What could have taken hours took 45 minutes. Let's lock in the 3 moves that turn debugging from panic into process. First, never jump to a fix. Isolate the source with divide and conquer and backtracing. Second, let Claude accelerate the heavy lifting. Searching, explaining unfamiliar code, and generating tests. Third, make the fix permanent by writing a regression test and getting it into your CI pipeline tonight. The fastest way to build real debugging skills is to practice on code you didn't write. Choose a large open-source project such as Visual Studio Code, Kubernetes, or another repository with beginner-friendly issues. Start with a small bug that you can realistically investigate and solve in a single evening. Apply the same process you learned today. Isolate the problem, trace it back to the source, ask Claude Code to help explain unfamiliar code, verify every recommendation, and write a regression test before you finish. The goal isn't just fixing a bug, it's building the confidence to debug any code base you encounter in your career. If this series is helping you become a stronger engineer, subscribe and follow the Claude Masterclass playlist. In the next lesson, we'll explore Claude Code best practices, the habits and workflows that help professional developers get the most out of Claude Code every day. If you have a debugging story or another topic you'd like us to cover, leave a comment below. I'll see you in the next lesson. Thanks for watching. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.